A ship anchored off a straight shoreline that runs north and south. So let's draw that shoreline, north and south. We're going east. Yeah. From two observation points 18 miles apart on the shore. So we'll name our observation points. Let's call them A and B. And they're 18 miles apart. So 18 miles is the distance between them. The bearing on the ships are north 31 east. So that's going to be the one on the bottom, right? Because the bearing is north 31 east. So that will be, try to draw it about right 31. So this angle here will be 31. That's north 31 east. Got it? That's how you draw that. And south 53 east. So from here it's going to be south 53 east, which is going to be a little bit more. So fortunately I made it like that. So that seems about right. 53. What is the distance from the ship to each of the observation points? So here's your ship, call that S, to each observation point. So they want these two distances. So we have a triangle. The hard part is always to draw it, or one of the hard parts is to draw it. And then now it's a question of how do I solve for those two sides? Well, I can't use law of sines because I don't have a side across from an angle, right? Actually, I do have a side across from an angle. I just lied. This angle is what? I have to solve for that angle, and then I can find it. So those three add up to what? 31 plus 53 plus x equals 180. So subtract 53 and 31, subtract 84, 96. And you get 96. So that is 96. So actually, I can use the law of sines. Now I can use the law of sines. And what's the law of sines say?
Sine of A over
sine of 96 over 18 equals?
Sine of...
whichever one, 53 over B, so we'll call this B. So you can solve for B, and then you can do the same thing and solve for C. Which is that one there, C. Sorry, I was just stupid there. I called that B, but this was B down here, so let me change that. Let's call that A and B. This is A, small a, and this is small b. So there we go. Now solve for A and B. So you get A equals 14.455, and B is approximately 9.322, if I did my calculations correct. And I'll just trust that you can do the sine inverse of that and use that in your calculator.